Hello, ladies and gentlemen. Today we're going to be continuing our conversation on frequency distributions. However, it's going to look a little different because when we say grouped frequency distributions, now we're going to be talking about how to organize data into tables when we've been researching quantitative data. So quantitative data, remember, is data that has some sort of number attached to it. So when it comes to organizing quantitative data, it's going to be different than how we've been organizing qualitative data and frequency distributions. So what you're going to need today is your notes and a pen or a pencil, and hopefully you have the full. Okay, so again, a grouped frequency distribution is just a table that is used when we have quantitative data, and it's used when our range of data is very large. The smallest and largest possible data values in our classes are going to be the lower and upper class limits that are going to create our class boundaries, and those class boundaries will end up separating our classes, which is also kind of like our categories when we did frequency distributions with qualitative data. So to find a class boundary, we are going to average the upper class limit with one class and the lower class limit of the next. This will create the class width, and then we can also use a class midpoint, which is calculated by averaging the upper and lower class limits once we have those class limits. So all these words, all this gobbledygook that I just said will make more sense when we look at a problem. Like anything in math, once we start working with numbers in an actual example, then we start understanding what all this means. But all this stuff that is written, hopefully you've written it all down, will help you to refer back to it once we've done the problem, just in case you're looking at the math later and you're like, wait a minute, how did I get that again? So make sure you write this down as well. Okay. Here are some more rules for when you create those categories or classes in your grouped frequency distribution. There should be somewhere between 5 and 20 classes. Also, I will always tell you in the problem how many classes to create. Those classes must be mutually exclusive, they should be continuous, they should be exhaustive, and they must be equal in width. So when we say mutually exclusive, we mean that they cannot occur simultaneously. So if we were talking about height in a particular class, like all the students' height in Mrs. Kincaid's class, we can't have one particular data point fall within two categories, because then how do we tally it? How do we organize it? So we have to have categories or classes created in a way that are not overlapping. That's what we mean by mutually exclusive. Continuous just means that we can't make any we can't skip from one class to the next. Like we should be able to go from like 5 feet to 6 feet when we talk about height. Like we shouldn't skip the category 5 feet, 5 inches. Okay? Classes must be exhaustive, which means that there should be some sort of tally in one of the classes. And then, of course, classes should be equal in length so that we're not looking at a graph that has misleading axes. So this is the data set that we are going to organize. This is the quantitative data set that we are going to organize or construct into a table. So the following data points represent the record high temperatures for each of the 50 states. Construct a grouped frequency distribution, and we're going to use 7 different categories, or we're going to split it up into 7 different classes. So that's what I mean by I will always give you the number of classes to use. So we're going to create a table by organizing all of these data points into 7 different categories, okay? So this data set, if you were to look it up, I believe is a little outdated. I think I pulled all of these record high temps maybe 4 or 5 years ago. So if you look up these data points, they're a little outdated, but at one point in time, Mrs. Littlefield did look up all the record high temps for each of the 50 states. All right, here we go. We have some steps in creating our table so that you don't forget. Step 1 is to determine the classes and the class width. So we are going to find the class width by dividing the range by the number of classes. So if we go back, our highest data value minus our lowest data value will give us our range. And we also said we want to split up this whole entire data set using 7 different classes. So we're going to take the range divided by the number of classes, which was 7 in this particular example. So the range was 134 minus our lowest temp was 100, all divided by 7. 134 minus 100 is 34, divided by 7 will get us a decimal of 4.857. Okay, when we round for creating class limits specifically, there's a rounding rule that we always round up if there's some sort of a remainder. A remainder means if there's any decimal. So even if our decimal was 4.111111, we would round it up to 5. So our class width, oops, I meant to put class, sorry. My mind got a little ahead of my pen. Class width will be equal to 5 data points. So we rounded that number up to the nearest whole number because our class width should always be a whole number. We're going to make it up to 5. So what we are going to do is we are going to start, when we create our class limit, now in the table, we're going to start at our lowest data value, no matter what that is, and then we're going to add the class limit down. So it'll go 100 to 105 to 110 to 115. So we're adding that class width down. We're adding that class width down all the way till we have 1, 2, 3, 4, 5, 6, 7 categories, right? Then what's going to happen is we will go one number less than to end the class limit. So when we say add the class limit down, why are we adding it down instead of across? Because when we talk about including the numbers in our classes, that's how wide our class width is. So if we look at this first category of data points, we're saying any state that had a record high temp between 100 and 104 will be classified or will be organized into this first row. So if a state had 100, 101, 102, 103, and 104 as a record high temp, it goes in this first class limit. Look at that. That's 1, 2, 3, 4, 5 data values. That's why our class width is 5, because we have 5 data values in that first class. It gets a little confusing because 104 minus 100 is 4, but when we count our class width, we're including the number at the beginning. We're including that 100 as well, which means that we will include that 100 to get us to a class width of 5. So that's how we construct the class limits. Okay. So some things to keep in mind, I already said this, but we always choose the lowest data value to start our first lowest class limit. And then the subsequent lower class limits are found by adding the width to the previous lower class limits. Like I said, add down for our class width. Okay. Step number 2 is filling out that column that's titled the class boundary. The class boundary is going to be a little tricky to find because it's halfway or midway between the upper class limit of one class and the lower class limit of the subsequent lower class. Let's see what I mean by that. So here's what we're going to do. Class boundaries. So if you notice, sorry, let me back up to class limits. Class limits are mutually exclusive. There is no overlap of the data point 104 or 105. It's mutually exclusive. Class boundaries are purposefully set up so that this number is the same because it has to be halfway between 104 and 105. And the same thing with 109 to 110. They're going to be the same number. Okay, so that's how we found all the class boundaries. Now comes probably the hardest part, and I say hardest because it's so easy when we have a big data set to mess up or make a mistake on tallying the numbers, is the frequency. We have to count how many data points fell between 100 and 104, how many fell between 109 and 105. We have to tally all that up. That's our step number 3, is tallying all that up. So if you need to take a second to pause the video and tally that huge chart that was listed all of our raw data values, you can do so. You can pause right now. But after you're done counting, hopefully you get the same numbers that I do. I found 2 data points in the category from 100 to 104. I found 8 in the next category, 18, 13, 7, 1, and 1. So hopefully that's what you found. You can double check my math, but I've triple checked and I'm pretty sure those numbers are right. Okay, cumulative frequency. Cumulative frequency is found by taking the current class, so like the frequency of the current class. So for this first class or first category of 100 degrees to 104 degrees, we have 2 data points. Then when we go to the next class, we're going to add the previous class. So think about cumulative when you hear like a cumulative test or cumulative score. It's taking everything that you've learned throughout the whole entire semester. Like a cumulative test says, if our semester test is a cumulative test, we're taking everything from the beginning as we've learned it. So we add the frequencies of the class limits down. So 2 plus 8, 2 plus 8 plus 18, 2 plus 8 plus 18 plus 13, 2 plus 8 plus 18 plus 13 plus 7. I think you get the picture. And we should always make sure that that last number is in fact how many data points we have. If we would have gotten 51, then we would have known that we messed up somewhere wrong on our frequency, or we would have added incorrectly for our cumulative frequency. Okay, step 5 is relative frequency. So it's taking that frequency column and dividing it by the whole or the total, because remember, relative frequency is that in relation to the whole, it's that percentage or fraction. So that would be this column. It's already filled out for you, like 2 divided by 50 is 4%, 8 divided by 50 is 16%, and so on and so forth. And then the last step is to find the class midpoint. The class midpoint is going to be the average between the upper and lower limits of the class, between class limits, I'll say. So it's like taking 100 plus 104 divided by 2. So 100 plus 104, here I'll write it up here. So like 100 plus 104 divided by 2. That would be an example of the average. So that'd be 204 divided by 2 is 202. That would be my first class midpoint. 105 plus 109 divided by 2 is 107. And so on and so forth. I think you get the point. So that is how you would find the class midpoint for all of those different things. All right. That is all I have for you today. So make sure you go back and thoroughly look through how we filled out all of these different columns in our table, because that is what today's goal is to organize quantitative data, so numbers, into a table, which means that we have to organize it into certain boundaries or class limits or categories, however you want to look at it. So make sure that you understand all the steps to setting up and filling out this table. Sometimes Mrs. Littlefield forgets the order in which that the table is set up. So sometimes you could go to class limits to frequency to cumulative frequency to class boundaries. So just make sure that you're filling out the appropriate column for the appropriate thing. And even if the steps are kind of out of order, that's okay. But yes, that is all that I have for you today. So I want to thank you for taking good notes, and I shall see you soon.